Okay.
Okay, thank you for your presentation. I have one question.
Yeah.
What is the relation can be established between CPU and GPU compute
By relationship, you mean working together or the difference?
together?
Okay, great. So going back, in fact, the big difference between CPU and GPU is the action able by each of one. Of course, you can use all the job on the CPU nodes, and you will be able also to use CPU as a GPU. So you will be able to push GPU jobs on CPU nodes. The fact is the GPU is more efficient for some kind of jobs than CPU nodes. And of course, a GPU node contain CPU because a computer, a server, in fact, can't work without CPU inside. So in each compute node, whatever the type, you will have CPU and memory. After that, you will be able to put CPU more powerful, big memory, or GPU inside. The point is, if you have only GPU into a cluster, you have to allow people to use GPU as a CPU node because some jobs will be more efficient on CPU than GPU and reverse. If you have a GPU jobs, you have to push it on a GPU node because it will be more useful. Many clusters will have CPU and GPU node to have a physical difference between the GPU usage and CPU usage. But if you have a cluster with only GPU node on it, you have to change some parameter in Slurm, the job scheduler, to be sure they will be able to be used than to let user to be able to use it as a CPU node. So both are useful in cluster and both will be able to work together, or you will be able to use CPU node like a GPU node. Is it okay with this question?
Yes, it's okay.
Thanks. Um, I'm sorry, Jose Ricardo can't hear me. If is everyone hear me correctly?
Yes, we can hear you from
Yeah.
here.
Okay. No, good. So it's fine. Okay, so I will continue with I had a little question with graphical interfaces on login nodes. That should be a quick question. Of course, on many cluster, we never put a graphical interface on it, especially on little cluster, because people who have a cluster generally don't like graphical interface, and of course you will be able to put security issue and bugs with graphical interface. So in many cases, maybe 80 or 90% of cluster we didn't have a graphical interface. Some customer wants graphical interface, and that is the customer choice. So we put graphical interface on nodes, login nodes, sometime on only one login nodes. If we have many login nodes, we maybe put graphical interface on only one node, but we have to put it. We have to do it, and we have to do it correctly and securely. We have to securize the interface, and to be sure we will not put a lot of bugs. So that is for the graphical interface bugs. I will maybe get a little more time on the racks and PDU. The question was for the PDU. What this means? It's power distribution units. It's what you are able to see at the middle here, and at the right place here. You have a non-manageable PDU, simple PDU with power inlet and power outlet for different kind of server. You have also manageable PDU. The main difference is these parts. You will be able to connect an RG45 cable on it to be able to manage it remotely from the network. The manageable PDU allow you to have statistics on the power consumption of each port, to have a remote control on it. For example, if you have a short circuit on one server, you have a fuse who will go out here under the connector, and you will be able to put it back remotely to activate it remotely again. So you will be able remotely to have a full control of each connector or on some nodes on parts itself. The PDU will be able you could put the PDU on different parts of the racks. You can put it like this, like a server. You can put, you will be able to put cable arm like this to manage cable properly. You don't have cable everywhere on the rack. You will be able to put PDU at each side of the rack, maybe integrated in the rack directly to optimize the use place or to optimize the cabling. Of course, the number of PDU depends on the number of server you have inside. The power on it's the same, and the power capacity too, because your power, your PDU, your power distribution units, will have a power inlet. This power inlet have a maximum capacity on the data center infrastructure. So maybe you will have, generally you will have 16 amps, 32 amps, 64 amps. That is a standard, and the more common power capacity you will find for the inlet itself. After that, you will have fuses on each connector, each plugs, or on each rail of plugs. Generally, you will find 8 or 16 amps fuse protection. Of course, you have to manage it to be able to share it properly between each server and don't go above it, because of course they will go out, shut the electricity and shut down your server. It's a power supply. It's also a protection tool because that will be able to protect equipment. You didn't have individual protection on it. The individual protection, the protection for people, is on the customer infrastructure, the data center infrastructure, the room electric panel. And think that's all for the explanation, more explanation. Did you need more information about specific parts on the rack and power?
No.
Quick answer. Okay, thanks. Did someone have other question on the component aspects? Maybe on previous aspect also, don't hesitate if you have any question.
I think no questions.
Okay. So let's continue with the aesthetics aspects. Into a data center, into an HPC project, generally the aesthetic aspect is for commercial people, communication people, for journalists, press, because a cluster is the image of an institution, a company, a customer. A data center could be beautiful and could be, what we say, some kind of pub, could provide an image to the company. And it's also in some kind interesting for people who visiting company to see the building, the data center, and the HPC cluster. So the aesthetic aspect didn't help you for performances, user, scientist, but it's also an important aspect of a cluster. Different aesthetics type. You will have door, you will have rack, side panel, server itself. Server itself could be beautiful by man, and it's another important aspects. For example, if you look at Curie in French CEA, it's a picture a lot of people see around the world because it's a public one, like Summit in US. Everyone knows this cluster. It was a bigger one, it was a powerful one, and it has a specific aesthetics aspect. Doors, etc. Don't forget the aesthetic aspects could also impact you in the maintenance, because if you have some cable to change, some server to change, in some way you have to dismount some panels, some doors, etc. So it's an important aspect to take in account. Of course, the cabling aspects, because if you open the door and you look at server, like, I don't know, cable everywhere, you can't be able to see server, etc. It should be a nightmare for the maintenance and for the visual aspect of it. Cable arm, cable tree, door solution. The door solution is a simple way to hide non-aesthetic cluster. That was the quick view on the aesthetic aspects. I don't think we will have question on it. We'll be able to speak about the feature. The feature is a more important aspect on the cluster. You will have to increase the capacity of the cluster depending of your needs, depending on the market evolution, customer problem and solution. So what will be the next point, the feature of a cluster? The Quantum. You will maybe need a Quantum processor in the future. That for sure, that will be the feature of a cluster. So you have to take in account the Quantum. It's already powerful and need a lot of electricity and will provide a lot of hot water, hot air you will have to manage. Processor will evolve, of course. AMD, Intel, who was be able to see that AMD will gain a lot at HPC market some years ago. So you have to take in account the processor evolving, the architecture evolving, and of course, the memory DIMM, etc., will be impacted by that. The network too will evolve. You will have a more powerful network, more quick network, different solution. For example, a couple of years ago, QSFP, SFP did not exist. Ethernet was less quick than today. So maybe today it's 100 gigabyte by seconds. Tomorrow it will be 1 terabyte by second, and your business will need it. So it's also an evolution, and you have to take into account. GPU, it's the same. Today we have a GPU. We have a problem to ask and get GPU because the market it's totally overflow by GPU. Storage, it's the same. We have disks at 8, 10 gigabytes 20 years ago. Today we have 1 terabyte by disk to 8, 20 terabyte by disk. We have storage at 1 peta, and it will be always the same. You will may need a second disk array or new rack. So you also have to take into account when you build a cluster solution. So 2 aspects: material evolving, if you need to change CPU, blade, etc. Network, if you need to change cable in your cable tree, cable in the data center. And cluster itself, if you want more rack, new infrastructure, and evolve your infrastructure. Cooling aspects, adiabatic tower, power, etc. So always take into account the future and always think about the future. That was for all the hardware component itself. If anyone have a question on all their aspects, it's a moment.
Any questions, please? Tom, I think no questions. Please
Okay,
go ahead. Yeah.
sure. So we spoke about space, power, and cooling of your future cluster. So your infrastructure. First of all, you have to choose a localization and an impact for this localization. It's not because you are living in America, Asia, Africa, you need your cluster in Africa. For example, you will be able to put it on the Arctic Circle to optimize your cold. You will be able to put it in Europe to have more efficient people to work on it, etc. So localization, it's an important aspect, and you have to focus on advantage and risk. First of all, a cluster will produce a lot of warm. So it's easier to manage it in a cold country or cold place than an hot place. For example, it's more efficient to put a data center in a mountain than in a desert. That's the first aspect for the cooling parts. It's the first point to optimize it. The second point is people working in the cluster. An HPC cluster will be managed remotely. You will be able to connect it remotely. You will be able to work on it remotely, but maybe some people prefer interact directly with the cluster, be in the data center room, be in an office near the data center room, etc. Of course, the cluster also need a maintenance. So you will always have people who need to interact with the cluster and go to work into the data center room. That is for the second choice. If you put it into a city, near a city, or far, far from a city. This could also influence the power price because the cluster will consume a lot of electricity. And the big price of cluster is electricity. If you buy a cluster at 1 million euros, you will put 1 million euros in 5 years in your cluster for electricity. That is a fact. So be careful of the localization for the electricity price. Of course, you also have to take in account that the electricity could be unstable on some parts of the world. So it could also impact your business. The physical access is also really important. If is into a city, no problem. You could have people living in the city going in the data center for any emergency. It could be quick and no issue. If you put it in Norway or in North country, in a mountain, taking account that okay, you will optimize your cooling system, but maybe in some season it should be difficult to going to the data center for maintenance to access to it. So it's another aspect. And the last aspect is the network connection. Of course, if your office is at the same place as the data center, you will be able to connect to it quickly. You will be able to manage it quickly with an efficient network, but in some or many cases, you will have to connect it remotely. So you have to take in account the fact that you will need an external connection to internet for external user, to a VPN, more prefer, or also to a data center or a sensor or some of the points that will provide fresh data to the data center, to the HPC cluster, because your HPC cluster will need a lot of inputs for the jobs. You will need sensor, you will need schematics, you will need financial data, you will need consuming information, a lot of information, and you have to transfer it. So of course the network is very important. Advantage also mean risk. The main two risks for a data center is the water and fire. You don't want to see your business under the water or in fire. So when you put a data center somewhere, taking account that you are not in an area who will be submerged by water, who have some rain problem, or all risk linked to water. For the fire, it's exactly the same. Taking account the area will produce a lot of warm air, will have a lot of hot water, and you have to manage to evacuate it and to have an environment who will not burn easily. The same, if you put your data center into the desert, it should be a nightmare to manage it, to code it, and for all this kind of aspect. In French, we have some area named CIVISO, all area at risk, nuclear, chemical or industrial big company will be a risk for your data center, because their company will have a higher risk to burn, to explode, or to do any kind of contamination or risk like this. So of course, put a data center into an industrial area. It's a good idea because you will pay your electricity at a lower price. You will have people near the data center, be able to work on it quickly, to be efficient on it. But you have also other company into this industrial area that could be a risk for your data center, for your business. And the last point, of course, it's war, terrorism. Some area at risk for that. A data center is generally linked to financial aspects, political aspects, military aspects, and will be the target of people. So taking account that put a data center in a war area, it's not a good idea, especially if you need to access on it and to do some job on it. After choose place, you have to build your building. Your building could be an independent building with only the data center inside, or could be your usual working area, an area you usually work on it, working place. So you have to secure the room itself. So for the physical building, you have to take in account the physical security of this building, put some protection for the water, be far from tree for all the fire risk, put some portal, some camera, badge access for the security access. And it's the same for the room. Taking account that the room, the data center room have to be accessible for the maintenance. So near a place to do the maintenance of blade, people maintenance, etc. But also good access for the truck, because you have to put in place a rack server inside. They are heavy, they will take a lot of place, and you will need a big door, a specific corridor, and of course a truck access for the delivery. That's the most important part when you want to build your building. Of course, take into account that you are not under the sea level. Put a data center under the ground level. It's very interesting for the cooling aspects, but could be a nightmare if you are near the sea or any water lake or something like this. Of course, put a data center at the high level or maybe last level of the building. It's not a good idea too, because it's really heavy, and you will have a cooling system in all the case. So you will have to put water in this room or water access to this room, and you don't want to have a water at the high level of your building, just to prevent any water risk. That's for the main parts. And we will going on the power parts, power aspects. Did someone have any question of the building localization?
Thank you, Tom. I, of course, the fact that water and fire could be dangerous to data center, of course, it's very critical. But my thinking is, especially in the area of water now, Isn't there a way one can tap on the natural environment, maybe to achieve cooling within the data center, which could consequently minimize cost of energy to achieve that? Thank you.
I misunderstand your question. You spoke about the water for the cooling parts aspect. Hello?
Yes, how one can tap into the natural resources of the environment.
Yeah.
Hello.
Oui.
Um, what the highest temperature that is allowed in a HPC in the cluster?
Okay. The temperature for an HPC cluster, it's depend, of course, of material inside, but generally you have to maintain the cluster room on all the material at a temperature less 40 degrees. 40 degrees, it's a maximum for the good functioning of a cluster. Of course, your environments could be higher. For example, if you are in the desert, you will have temperature higher than 40 degrees. But you will be able to have a temperature lower into the data center room, but it's more difficult to maintain it. If you have a very big sun during the day, you will have your cooling system less efficient. You will have a data center will increase more quickly the temperature, and it should be less efficient cooling it, and of course more um, more expensive to cooling. So the temperature, it's more financial aspects than a risk itself, because the risk it's only if your cooling system it's not enough efficient or fail, you will be able to burn your system and broke it. So it's not a really big risk, is more than the advantage or critical points for the cluster.
Thank you.
You're welcome. That was for the cooling and fire question, but I hear also a question about the water risk, but I didn't understand it.
Okay, I think in a way you addressed it. My question is, can't someone tap on maybe the availability of water within the environment to achieve cooling? Natural resources like water now to achieve
Yeah.
cooling. That's what exactly my question.
Okay, thanks.
Because I'm also aware that some data center are located underneath the ocean, and I'm sure cooling is maybe one of the reasons, one of the factors that would make such to be done. Thank you.
Yeah, I better understand the question. Thanks. So of course the water could be an advantage depend of your water cooling system. If you use water to cooling your system, for example, if you have an adiabatic tower, if you use a losing water system to cool your cluster, have a water source just near your cluster, it's good. Some people also try innovation by do a data center under the water directly. So a container into the sea, a container into the river, a direct access to the river to cooling your cluster. Of course, all of their solutions will be efficient, but also have a risk. And you have to take this risk in account because you will work with electronic components, you will work with electricity, and it's not a friend of water. So your solution could be efficient, could be could be really useful to have water near your data center, but you have to take it also at a risk for your cluster, for your infrastructure. For example, if you're in if you are in a desert and you want water for your cooling system, should be critical to obtain it, especially if the cooling network, public cooling network, or if you need trucks, could be a nightmare to get some water. Nightmare than if your data center are near the sea. But near the sea, it's another problem. You will have too much water because if you have a climatical problem, that could be damage your infrastructure, or if you have a leak, a big leak into your water infrastructure, should be also another problem. So yes, water could be an advantage, but also a risk. I hope I answer correctly your question and give you enough information.
Yes, thank you. So there are more questions.
Yeah.
All right, Tom. Thanks for this knowledge. I'm just thinking that most of the building in Nigeria, especially in Nigeria, the aspect that you said, truck entrance, the location should be able to have truck entrance. Can you please go to the slide? Yeah, truck
Yeah.
access. Most of the buildings in Nigeria, I can speak of Nigeria, do not
Yeah.
have truck access.
Yeah.
And I'm thinking that, of course, you can't put your data center at the top of the floor, at the top floor, and as well, you can't put your data center at the bottom floor, because at the top floor, you might have issues with water, which we are trying to avoid, and as well, at the bottom floor, you might have issues with a multiple access, which you are also trying to avoid. So I'm putting up an idea of the middle floor, where you can restrict people from entrance. And now that middle floor pertaining into most of Nigerian architectures don't have truck access. Why did you suggest truck access? Is it because the equipment are fragile? Is it because the equipment needs to be, they are heavy, or must we look for that truck access? Must we consider that truck access, or it's just an opinion you are giving?
Complex question. In fact, first of all, when I spoke about the place of the data center room into the building, I'm always spoke about advantage and disadvantage of each situation. All situations are possible. You can put a data center at the top of your building or at the bottom level. Also at a level under the first floor, under the ground. But you have to take into account advantage and disadvantage. When you will install your cluster, you will have big quantity of material, rack, server, pallets. That will be a big amount of material you have to carry on to the data center room. So if you are not at the ground level, you will have to use an elevator. If you have only step, it should be really funny situation. If you didn't have a truck access, you have to maybe roll the racks or roll the trans pallets to the entrance of the building, to the corridor, to going to the data center room. It's again, it's always possible. All situations are possible, but it will be more complex. It will put you some difficulties, more difficulties to put it in place. So it's not like you have to do it like this, or a data center have to be like this. It just take it in account because it could put some difficulties to install it, to maintain it, to have an efficient usage of your cluster, or put you at risk also because transport a rack into a step, it should be really, really dangerous. So it's, yeah, it's more like advice, or more like a fact to keep in mind, I think.
Okay, thank you very much. Oh, so we have one more question.
Yeah.
Okay, thank you. I have a question for the big data center. Maybe there are some assurance company that are covered those big data centers.
Yeah.
Those companies are covering only the building, the hardware, and maybe the software. Are they also covering the data according to the amount or according to the sensibility?
That's a good question. In fact, everything is possible with insurance. Depend of what you want to insure and the usage. Of course, if your data, you will be able to generate your data easily. Maybe it's not really important to lose it. Maybe it's not necessary to have an insurance. Every part of your cluster of your building would be able to have an insurance on it. You will insure from fire, climate problem, water, warming, etc. Your building could be covered, and all material into your building. Your data could be covered. If, for example, you can take first of all, of course, you can take security, RAID 1, RAID 2. You will be able to put different racks, share storage, share data, etc., to prevent any problem like this. But in last point, yes, of course, you can get an insurance to protect your data. Insurance, for that, you have a specific company to provide insurance. Or you are, classical insurance company could do it also. The fact is, you have different aspects where you can put an insurance. For the software aspect, first of all, if you choose a software solution from a company, for example, Atos, IBM, and so on, you will be able to subscribe a support for your software. The support will provide you all the updates, can provide to you also a technician to maintain your cluster software, to do the manipulation inside, can also put insurance on the version, etc. If you use Red Hat, for example, Red Hat Linux, you will be able to have access to the Red Hat support, Red Hat insurance in case of problem generated by Red Hat itself. For the data, if your data cluster is provided by Cluster Store, IBM, Atos, in some case, generally those companies provide you some spare disk, and replace controller in case of fail, but can also provide you an insurance in case of data were lost by mismanipulation or misusage of the cluster itself. many different insurance exist and are possible. All insurance depend of what you need, what is the security you put in front of that. Maybe you don't really need an insurance for your data if you put all the security in place to prevent any data loss. Then, like the electricity, for example, if you lose electricity, you will lose all the data on your cluster who are in cache or job runnings. So you can have an insurance for your electricity provider, but you can also put a generator, you can put a battery solution to prevent any electricity you lose. So it's always balancing between the risk and what you need to be covered. I hope I answer your question.
Thank you very much, Tom. One more question, please.
Yeah, no problem. Go on.
Please, if you can go back to localization advantage slide.
Yeah.
Yeah, number 2 on the list there is hot. So how can hot be of advantage to data centers?
Generally, the hot area, I always have in mind deserts, but hot area, really difficult hot area mean also nobody here, no business, and no infrastructure. So if you want to install a data center in a really hot place, of course, you will have difficulty to manage your cooling, to manage logistic aspects, etc. But the price will be low. So of course, this could be a disadvantage on some points, but this could also be an advantage on other points, mainly on the price and the place space available. So yes, according to you, it's more disadvantage than an advantage, but could be an advantage.
Okay.
Thank you, Tom. I think no more questions.
Okay.
Yes.
So next part, power aspects. That is what you have between your power supply company and your data center itself, your cluster, your IT equipment. You have at the left side the simple view, and at the right side the technical view. On all the power supply flow, you will have, of course, the power supply, power line. You will have the HT cells, high tension cell transformer to transform your electricity. Secondary sources, if you have a power generator for backup, for example. Inverter. The LV boards and control panel are to control and secure your electricity, and at the end you will have the equipment. So you will find here the same, but schematically. You will have your high tension cell, transformer and generator, transformer and IT cell here, and generator here. As you can see, that is your normal electricity providing way. You will be able to put a redundancy on it to have two different power supply, and you will be able to put a generator if you are a really risk area for the electricity, or if you need backup electricity sources, you will be able to put a generator. That is the first power supply part, and the three possibility. First of all, the normal one, a secondary one to have a backup, and generator. you will always have a control panel to manage their different sources, manage the redundancy, and manage power share. Inverter and battery. In all the case, you will have to stabilize your tension, your electricity, but you also have to stabilize in case of power supply shorts. So battery will help you to provide any electricity even if you lose your main power supply. And it can also maintain electricity during the time your generator power on, because the generator in short case can take 20 to 30 seconds to start and to provide electricity. That is a minimum. So battery could be really useful. And at the end you have electrical panel, so you will be able to have different kind of electricity connection to your cluster. Depend on, for example, if you have critical parts, management parts, storage parts, etc. For the compute node, calculation parts who are less important to maintain, but you always need to have electricity inside. That is an example. To resume, you have your power supply, nuclear, water, a solar panel, etc. It's your electricity provider. You can't manage it. It's only for you, it's only a contract. You just have to manage the connection to your high tension cell to be sure you have a good contract, maybe a backup line, and you have the good price. HT cell, normally you don't have to really take care of it. It's the same for the transformer. Normally it's parts managed by the power supplier or the responsible of your infrastructure. Normally it's these parts have to be measured, put in place according to your final consumption and evolution. But after put it in place, normally you will not have any problem with this part. Power generator and inverter and battery. That parts depend of your power supplier. Again, if your power supply is not stable, if you are a critical business and if you don't want to lose any data, that is the gain parts. The battery is the first one, inverter batteries, it's the first one to put in place. Because if you have only short power lose, the battery will be able to take the role during a short time. If you have a really big room with a lot of inverter and battery, you will be able maybe to maintain electricity during 1, 2, 3 hours. Some battery room can maintain electricity during 1 day. Don't forget that an HPC cluster will consume a lot of electricity. So you have to adapt, of course, your inverter and battery between 2 points, how many time you want to maintain your services, and the price. If the price is too high, the power consumption is too high, you can add a power generator. Also, if your power supply can be short many time and during a long time, it's really useful to have a power generator. LV board, control panel, that it's an important part, but more for the security and for the monitoring. You will need to maybe to monitor your power consumption, to maybe cut electricity remotely. If you want a remote control, you have to take care of what you put in your control panel. And a second aspect is the security. You will have breaker, you will have fuse, you will have individual protection. The control panel, it's really important to protect your equipment and your team from any electricity damage. And at the end, your cluster, your HPC cluster. And into your HPC cluster, your electricity is maintained, of course, by PDUs, and you will be able to put also battery and inverter inside your data center room. But when you have a data center, it's more efficient to have an external battery and inverter before the last control panel or before the LV boards. Electricity, so three aspects to take in account. The price. Your supplier will provide you a price depending of your power consumption. You will be able to manage your contracts if you need or not big availability from your supplier. In some region of the world, it's more efficient to get battery and power generators than contracts ready with high availability with your supplier. For example, if your supplier say, maybe I will cut the electricity 1 hour by months, a couple of batteries should be enough. If he spoke about 1 hour by weeks, power generator, a battery will be needed. But if your power supplier will cut you 1 hour by weeks, your price will be also really, really lower. So you will be able to maybe manage to have a lower price with your supplier and put more money in UPS and inverter. The power is the second aspect to take in account. Of course, your cluster will consume a certain amount of electricity for normal use, but it will also have spike of power consumption. It will have jobs who consume more electricity than other. So you have to take in account for your infrastructure, for your price of the electricity supplier, etc. You have to take in account the maximum power consuming of your cluster. And of course, you will evolve. Your cluster will evolve. You will maybe put more racks, more server, depends of your needs. You will evolve your cluster, so it will consume more electricity. Generally, we take an account for the evolving, for the future of your cluster. We take in account 30% of evolving. So you have 30%, it's more like an advice. You have to take 30% of electricity capacity more. You have to do the same for your cooling parts, for your data center size, etc. Again, it's just an advice, but generally is that. And the last point is the security. Of course, you will have a really big quantity of electricity. You will have high voltage into your data center, so you have to prevent any damage for your infrastructure, for your system, because your system is a lot of money. And you also have to take in account people, because electricity it's a dangerous things and could kill. So you have also to take in account the people security when you install a building. Same for the power redundancy, inverter, UPS. You have to take in account which part is really important on your cluster. Generally, the important parts is the storage and the management parts. The storage for home user, scratch, so data. You have a lot of customer data, you have a lot of jobs data, you have to save them because their data are money and you don't want to lose your money. The management node, it's more for the life of your cluster. The management node, it's a node who will be able to restart properly your cluster, to redeploy your cluster in case of problem, to manage your cluster, so you don't want to interrupt it. It's the main part of your cluster is the management node, and you have to take care of it. The compute node is less important because the compute node, if you have any problem on the compute node, you can kill it, you can reboot it, you can redeploy it, you can restart it in case of power losing. Is less important. The more important part on the compute node, it's the job itself. Because when your cluster running, you will have jobs running on your compute node. And if you interrupt this job, you just have to relaunch it. For such job, some jobs have 1 hour, 2 hour during. That is okay. You lose 2 hours. It's not a big deal. Some other jobs takes 1 or 2 days or 1 week to running and before you have any results. So it's if at that day 4 or 5 you lose the 1 week jobs, you will have to do it again. So you will lose 5 days of production, and that is a big problem generally. So you have to adapt your power redundancy between security and money, because of course they are really expensive equipments, but your data, your jobs, your business could be also really expensive if you lose it. So the power redundancy, it's a balance between money and security, and you have to adapt it. We will going on coding aspects. Did someone have any question about the power aspect?
Thank you, Tom. My question is not directly on power, but I was just wondering, the data center looks massive, infrastructure, very big. I was wondering how the industry is dealing with obsolescence. I know that the kind of data centers we used in the past are not the same now. How is the industry dealing with obsolescence, movement in the trend of, like I was wondering, the kind of structures we are seeing now, sometime in the future, may not, we may have moved from there. In the past, how has the industry been dealing with the ones that are already obsolete? I was just wondering. No, incidentally, Africa is not a consumer of that sort.
Yeah, no, that's a very good question. Generally, we consider an HPC cluster to be obsolete in 5 years in European Union. Generally, each cluster is changed after 5 years. Of course, your infrastructure may not have to be changed. Your electricity power consuming will evolve a little, but not a lot. So you will not have to buy or install a new power supply, new battery, transformer, etc. Generally, on the electric aspect, you don't have to change it. You just have to adjust it, to evolve it a little. Maybe the electricity connection, etc. It's the same for the cooling parts. Your building will have cooling system. The cooling system was adapted to your data center, to your server in the room. Generally, it's the same. You didn't have to change it a lot. You just have to adjust some connection, maybe adjust a little the capacity, but not a lot. The main part is the system itself, servers, computes, racks, infrastructure inside the room. If you didn't have usage anymore of your old material, old components, you can let it, you can change only half of it and continue to use the rest. You can connect the new cluster to the old one. It's also a possibility. But in fact, material will be obsolete quickly. Previously, we give, before, 10 or 20 years ago, we taken account that system could be changed 10 years after. Now we spoke about more 5 years because technology evolved very quickly. So company like HPC company like Atos, IBM, Cray, Fujitsu, etc. Some company like this provide different solutions. They provide cloud solution for HPC. That is the easier way. You pay to push some job on the cloud and that all. Provide cluster with a little less price because they will get back the cluster after 5 years. So you will pay a little less your cluster, but you will pay more in 5 years to change it. So it's just a little amount to change it. In all the case, the company have to take back your old cluster to recycle it. So generally, to resume, in a data center, we didn't change a lot the infrastructure, we just adjust it. If it's a totally new infrastructure, of course, you have to take in account that your business will evolve, your cluster will be evolve, and you will change it, maybe not in 5 years, maybe in 10 years, but you will have to change it because your needs will change. And if you have already have infrastructure cluster or server into your room, you will be able maybe to find another usage, recycle it by any way, or just push it back to your provider to recycle it. I think that's all I have to say for this point. I hope
Okay.
I was clear enough.
Yeah, thank you for that explanation.
I have another question, please.
Yeah, sure.
I have heard in few moments ago that when we have 30% of evolution in our powering, we have to change more than 30%. We have to change our cooling system. Is it right?
So I misunderstand. You had the experience, or you?
I have heard in a few moments ago that when you have more than 30% evolution the um, of the of the cluster, you have to change the cooling system. Is right or?
Yeah, it's not. It's not that simple. When I'm when I spoke about 30%, it was when you create, when you put in place a solution, you have to take evolution margin. And this evolution margin, generally, we spoke about 30%.
Yeah.
So that margin is for the future. If your business just need a little more of compute, a little more of calculation capacity, you will be able to add compute into your cluster because you take in account 30% of space inside your cluster.
Yeah.
You take in account a couple of electricity margin. So you will not have to change the electricity infrastructure. You just have to put server in place. You have the place, you have the electricity, you have the cooling capacity. So the 30% are here for the short term evolving. So I mean the 5 years evolving.
Yeah.
It's more like a margin to didn't have to change your infrastructure. You will be able to add more material without change anything.
But if it is up, um, then 30%, what I have to do? I have to change some.
Yeah. For example, I would like to say an image. You have a business, you create your first data center, your first HPC solution, and you sell HPC time calculation to other company.
Yeah.
Imagine. Your cluster is really used. You use 100% of your cluster. It's more than you expect. All company take a lot of time with you, and you see more and more company who need calculation and who want to buy calculation time for you. You estimate this new business, more than 30%. In this case, the best way is not to evolving your system. The
But
best way is to create a new other system, to link another system. And in this case, you will have to, of course, going under the 30% of evolution because your business will evolve quicker than you expected. The 30%, it's the normal use, some kind of statistics, normal evolving.
yeah. Yeah.
It's not exact science.
Thank you very much. It's clear.
No problem.
Thank you very much, Tom. There are some questions on the chat box.
Yeah. Be used as principal source of powering HPC. So the second question will be really quick. Can infrastructure have multiple power sources? Yes. Yes, you can have multiple power sources. For example, you can have solar panel, you can have, I would like to say, a nuclear power plant. You can have, of course, you can have multiple power sources, and you can prioritize. For example, if you have solar panel on your building and you have some, I don't remember the term, wind rotor, you can prioritize it than the electric company. So you can have, of course, multiple sources and you can use it differently. The solar energy and the wind energy. Don't forget that during the night, you will not have sun anymore. And on some season, during some weeks, some months, maybe you will not have wind anymore. So if you put in place this kind of solution, solar energy, wind energy, you have to take in account that these sources will not be enough at some moment. So you have to put in place maybe a generator or maybe another sources, maybe the electric company. So yes, of course you can use solar energy, wind energy as principal source, but taking account the security, just to be sure you will not lose electricity during important time. I hope I answered correctly. You're welcome. Any other question?
Thank you, Tom. No more questions.
Okay, perfect. Let's go on. Cooling aspects. The most important points on each cluster is the calculation power. The calculation power is electric power. You will consume electricity to produce calculation power, and this electricity will be transformed directly to heat. Your cluster usage will influence your power consuming, will influence your heat production. And this heat production can be reused. For example, you can warm water to your building, to your shower, to your hot water supply, extra. You can use it to warm your building in some localization. When in Africa, I think it's not necessary to warm a building, but in fact, it's usage. But in all the cases, you have to evacuate it from your data center to recycle it, or just to put it in the air. Two kinds of system to evacuate here: air or water. You will see, I'm put an asterisk on water because you will see that in all the case you will evacuate with water. It's really rare. You will not use water to evacuate your heat. The only case you will evacuate it without water, it's a free cooling if you are in a really cold country. In that case, you will just take air from outside, go inside the data center, and the warm air will be pushed outside. For example, if you have 10 degrees or 20 degrees constant outside, you will be able to use a free air cooling system and didn't use any water solution. But in all the case, it's a two solution: air or water to evacuate your heat production. And more complicated, two charts to manage it: vaporization charts, psychometrics charts. It's a little complex. Maybe it's not useful for everyone to know it perfectly, but you will see that all the cooling system will use that charts: temperature, entropy, mass, heat, humidity, dry. You will see we always relating to that. First of all, to evacuate this heat to the cluster from the cluster, we will see that after. The more common solution are heat exchanger on the building. I simplify the explanation by black box like this. That came from Benoît Leveugle, and it's very simple to understand. You will provide to the heat exchanger hot water, for example, from your direct cooling system, from your climatic exchanger into the room, etc. You will have hot water. The hot water will going through this black box and go back to the data center at a lower temperature. For that, you will use electricity and you will use cold air or almost cold as possible. And you will be able to exchange this hot temperature from the water to the air directly. That is the first solution, the simple solution, the best solution, and the best solution for the price and the maintainability. And you will find it everywhere, like your air cooling system at your home or your building. It's this kind of solution. So it's the solution you will find everywhere. It's a dry cooler system. And to optimize it, to be more efficient, you will be able to use a adiabatic cooler system. The difference between the dry cooler system and the adiabatic cooler system, it's you will use water in your adiabatic system. You will, in fact, you will consume water and you will put some water out at the water form and vapor form. So you will use electricity and water to transfer your heat from the water to the air and the water. That could be sent directly to a river, a lake, a sea, for example. And a couple of this water could also be in air. The system will just spray water on this area to optimize the heat exchange. So you will see we find again this chart and we will play with this part exactly. We will increase the relative humidity from on this one it's from 30% to 80% to optimize the heat exchange. So here the dry bulb temperature. That is the dry cooler. It's simple metal plate with the water going inside and going outside. So the water will going into a little, really little section of metal pipe. And this little section is to the goal of this little section. It's to optimize the contact area between the air and the water. We use metal parts because metal have a really high heat exchanger coefficient, so it's a more efficient one. So that is a normal use. We're going with hot water here, and the air from outside will cold this internal water to going outside colder. To optimize this heat exchange, we optimize the size, the contact size, and we will optimize also the air contacts by fan. So we will create air movement from outside to inside through inside to optimize the heat exchange from the water through the metal to the air. That is the normal use. So the air here will become hot and the water here will become cold. And on the adiabatic system, we will add water on this part to optimize the exchange coefficient. So we will put the hot, the heat, the warm, the heat parts will going through the metal to the air and through the metal to the water. And like this, we will be able to decrease the temperature of the water. That is the first and main cooling system. We will see it at many customer sites, many different usage, and it's always the same. You will have an exchanger here to going from hot water to cold water through the air and to optimize it with the water. Another part of the system, it's a cooling tower. The cooling tower, it's exactly the same point than this one. Just this time, we will push water from the data center directly to the spray. We will spray this water into the air in a container area, and we have some fan to optimize this exchange here. So we will optimize a lot the heat exchanger between the water and the air. Of course, we will have water loss in the air, and the water loss is from the data center, so the water you will use into the data center. So of course you will have to replace this water because the water you spray to cold it will going through a tank at the lower level, so at the cold level, and you will send this water back to the data center. So to replace the water you lose during this process, you will push water, cold water, back to the data center. So this system will use power, water, to transform the heat from the inlet water to hot air and hot water, water and vapor. And you will send back to your infrastructure water from this system and also new water from your water supplier. So of course, for this kind of solution, like every solution, you have to take in account that you need water at any moment. So you have to take in account that your water supplier will provide you or will be able to provide you water whatever the hour of the day, or you have a tank to stock some water, to have some water to be able to use to the cooling system when you want. Something I didn't explain on the adiabatic parts, an adiabatic cooling solution is able to work without water, like the Senegal one. So you will be able to use it like a dry cooler. And when your cluster is at the maximum of use, or if your external temperature is not enough cold to be efficient with the dry cooler system, you will be able to use water to cold it better. So you will be able to use it as a dry cooler solution when your conditions are optimum, and use water in difficult solution or a really big usage time. I would like to go into the water infrastructure, but I'm see time running. Did someone have a question on the beginning of the cooling parts before we are going for lunch break?
Any questions? But I have a comment. The diagrams are quite small. We can't see the captions or
Oh,
the lettering. They are quite small. So from the middle, even from the front row of the class, we can't see the letterings or the captions of the
okay.
diagram. If the
So,
further images could be made bigger.
yeah, for example, you are able to see the power here, or is it too small?
Yes, it's too small.
Okay, okay. So after lunch, I will try to manage quickly to change a little the slide to put it more bigger.
Okay, thank you.
No problem.
I think no questions. Yeah, for now.
Oh, impressive. So everyone understand correctly? Quite hard. Okay, so maybe we can take the lunch break if you are okay.
Hello, Tom.
Yeah,
The lunch break is like an hour's time.
my.
It's, it's like it's an hour's time. So we still have 1 hour more.
Uh,
Hmm.
maybe I misunderstand.
Maybe
It,
maybe you are using France time.
yeah,
Sort of. Okay, West African time. We are 1 hour behind. We are
yeah,
1 hour behind.
yes. But you eat at 1 p.m. in Africa?
Yes, this is 12 in Africa now, in Nigeria.
Yes.
Okay.
From
It's
the timetable you shared with me yesterday, we
where?
agreed to use the West African time, and that's 1 p.m. African time for the break,
Maybe I
which will be
misunderstood.
2 p.m. your time.
Yeah, maybe I misunderstood this part.
Okay, you want us to go for break now?
Yeah, maybe we had a misunderstanding on this part. So if you are able to going, yeah, to break now, it should be the best for me.
That's fine.
Yeah, yes, my bad. No, it's that. Okay. So yeah, okay. It was a misunderstanding between us in the email. Okay.
Okay, no problem. We can go on break now. But for now, the lunch will not be ready for the participants. So I don't know how we're going to manage that. So going for lunch now. No, that means 1 hour.
Exactly, which will be 2 hours, and that would be too long. How affect the schedule? So what do we do? Ṣé wọ́n ló fún ní West African kìíní yẹn? Oh, wo dáadáa. 1 to 2. 1 to 2 is 12 to 1. Back to West African time. Okay, ó wà lókè. Bóyá ká pè gẹ́sà pé Jídé wá.
If it's okay on your side, we can maybe delay a little the return time. Maybe we can go in back at 1 past half or maybe 2 p.m. if you need more time to organize or.
Tom, no problem. We come back by 2.
Okay.
No, around 2 p.m.
Yeah, 2 p.m. for you, 1 p.m. for me. 2 p.m.
It's going to be 3 p.m. for you.
Okay. 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 Okay for me, no problem. So we'll do it like this? Okay. So see you later.